with this topic. And what is the name of topic? Next experiment. Sun experiment. Okay. Sun experiment. What is the another name of sun experiment? High energy particle experiment. Actually, to perform this experiment, massive energy is required. Okay. For this kind of experiment, massive energy is required. Because massive energy is required, this is called high energy particle experiment. This is also called as European concept for nuclear research. This is also called as the European concept for nuclear. Actually, it is the main leading research of European Union. But India is also associate member. Okay, India also the associate member of this experiment. Earlier, India was not the associate member. India was just the observatory nation, just to do the observation studies and all. But now India became the part of this research work. So I can tell you, in the present scenario, India is an associate member of Sun experiment. Okay, India is an associate member of Sun experiment. Actually, those four Indian experiments are formed where is a Swiss France border. It's a Swiss France border near Geneva. It's a Swiss France border near Geneva. This is the place where the entire experiment performed. So Swiss France border near Geneva. Okay, guys. So this location still is important, I can remember. And this research I will also tell you, it is a big research, mega research. What is the meaning of mega research? I think you remember. At one place I told you mega research means what? Those research have a requirement of massive money. Those research have a requirement of massive scientists. And many countries' contributions together. These type of research are considered as a mega research. So Sun experiment also is a type of a mega research. A massive level, many countries are working together. That is okay, the European country play the main leading role here, guys. Massive funding for Sun experiment when European countries are generating. But India still is an associate member. Okay, fine. So this is the mega research. Okay. Actually, the question is why this experiment is required. To answer is very simple, because we wanted to do the study of dark particles. We wanted to get the knowledge about the dark particles. Okay, we wanted to get the knowledge about the dark particles. Dark particle is also called as what? Higgs Boson particles. Dark particle is also called as the Higgs Boson particles. Definitely, I'll tell you why the dark particle study is important. Wait. But another name of dark particle is what? Higgs Boson. Actually, here two scientists name used. Two scientists name is used there. The one is called the Peter Higgs, and second is called as the Professor Satyendra Bose. Professor Satyendra Bose was an Indian scientist. Okay. These two people contributions, because of these contributions, everybody understood what is a dark particle. Fine. Actually, to detect about the existence of dark particle, scientists developed in this experiment what? Particle accelerators. Accelerator where you can do some acceleration, increase the speed of something. Okay, a good shape of accelerator you can develop for the study purposes, linear shape and circular shape. But in this experiment, circular shape accelerator used. Three types of circular shape accelerator used here, guys. The one is cyclotron, second is the synchrotron, and third one is the last atomic line. Step by step, cyclotron is the smallest, synchrotron medium, and large atomic particle is the biggest one. You know, the size of the large atomic particle is around 27 km length. 27 km length. And whole entire experiment performed deeply inside the rock. Okay, it is a tunnel. A deeply inside the rock, a tunnel formed. And inside the tunnel, entire experiment performed. The reason is that if any kind of electromagnetic waves will reach there, if any types of electromagnetic waves will reach there, okay, the whole entire experiment can destroy. Electromagnetic waves, very simple guys. From the solar radiations, massive electromagnetic waves are coming. X-ray, gamma, micro. Even in the night, guys, still electromagnetic waves are coming on the Earth's surface. After reflection from even the star lights. Yes, and other star lights. So this is the reason with this experiment performed deeply inside the rock within a tunnel. And the last accelerator is also collider, because here some collision performed. Not only the acceleration of the speed something, even collision of something happened. And that is it is the accelerator and simultaneously it is also called the collider. And this is the final place where actually we will do the study of dark particles. And in this accelerator and collider, I have actually presented up different types of powerful cameras. These powerful cameras we call as a detectors. And those detectors are used as Atlas, LIs, CMS, and LST B. B for Bombay, small b. So these are the name of ways where the various accelerator used. Sorry, detector used for the detection of dark particles. And see, in this experiment, I think you people remember, guys. I told you those antimatter discussion I told you earlier, guys. Okay, antimatters. Okay, antimatter discussions. Antimatters. Antimatter also develop under CERN experiment. Okay, and this antimatter you will also get here in this case of CERN experiment. Those develop. Then this experiment, guys, indirect experiment, antimatter also develop for short period of time. Clear everyone? Antimatter is also developed here for short period of time. And now let us start this experiment. But first of all, the topic of the session: what is God particle? Actually, what is the God particle? Due to presence of God particle, guys, mass exists. So due to presence of God particle, mass exists. Okay, so mass exists due to presence of God particle. Okay, if mass exists, so what happens? Energy is there. If energy is there, guys, what happens? Existence is there. Okay, due to presence of God particle, mass exists. Due to presence of mass, energy happens. And due to presence of energy, everything exists in the Brahman. When anything is available in the Brahman, definitely without energy, nothing possible. And see, the reason behind the energy is what? That is the mass. Without mass, nothing exists. Without mass, nothing exists. So under the God particle is that kind of fundamental particle. Because of this mass exists, due to the presence of mass, everyone has an energy, and because of energy, they have a existence. Any small size of objects to any big size of body, everyone have a mass due to presence of God particle. I can give you an example. Just like a very small size example is a proton. And very big size, I'm telling you the example of celestial body. Celestial body, like any of the example you can write, Earth, Mars, Jupiter. Everywhere it is, either a small size of proton or big size of celestial bodies. Everyone exists in the Brahman because they have presence of God particle. Without God particle, nothing possible in this Brahman. I'm going to repeat, any small to small. Hello. So everyone, either it's a proton or celestial bodies, it's a very small size, it's a very big size. Everyone have what? Everyone have God particle. And everyone have a God particle, that's why proton, celestial body, everything exists. Okay, exists. Literally the God particle exists in the proton and all. I'll prove through the help of CERN experiment. Actually, in proton structure I'm going to form here. Suppose proton is made up by 2 up quark and 1 down quark. Proton is made up of 2 up quark and 1 down quark. Okay. See here, guys. This is 1 up quark. This is what? 1 more up quark. This is what? 1 down quark. What is down quark? The 2 up quark and 1 down quark you can see here, guys. Okay. But one thing I'll tell you, guys. Not only the quarks. In between have presence of the yellow color that I'm going to show you. This is what? This is a God particle. And this God particle can also tell as a boson particle. And due to presence of God particle or boson particle, this entire proton have mass. Did you understand or not? See this picture, guys. In this picture, what you can see, this is the entire proton. In this proton have a 2 up quark and 1 down quark. And what you got in between? Presence of God particle. And due to presence of God particle, everyone have mass. Did you understand or not? Actually, those fundamental particles I told you guys earlier. How many fundamental particles are available in physics? So fundamental particles are elementary particles. Those you are telling as a 17, guys. These fundamental particles are elementary particles. Those are 17 in numbers. They are described in 2 groups, guys. The one is called as a matter particle, and second category is called as a force particle. Those 17 fundamental particles or elementary particles are discovered in physics, modern physics. They are divided into 2 groups. The one group is called matter particle and second group is called force particle. Total number of matter particles are 12 and total number of force particles are 5. Okay, total of matter particles are 12 and force particles are 5. Actually, in this entire discussion, those quark you can see here right now in this picture. Actually, quark and similar many other example, rest of the 11 are the matter particles. And what is the force particle here, guys? The answer is the boson. Your God particle is what? Is similarly many of them is a force particle. So what you got here, guys? Definitely boson particle, due to presence of this mass happen, this work as a force particle. That's why all the quarks are connecting together and they form a proton. Very simple, guys. You all people are what? Quark. And I'm working in India as a what? For the science and tech and environment as a boson particle. I'm working as a force particle. That's why everybody is connecting with me for the understanding of science and environment. Understood or not? So I'm working in your life as your God particle, your boson particle. And you all the aspirant in India, they are what? They are my quarks. So you are quarks, matter particle, and I'm your boson, force particle. And because of me, everybody know about somebody is teaching the science and tech as a subject also. He is not telling the science is only current affairs. Clear or not? Okay, so this is the concept. Now literally this God particle, yeah, boson particle exists or not, that discussion I will do. But I think you people very clear. Those fundamental particles you have seen earlier, guys. 17, they all are grouped into 2. The one matter and second is the force. Matter particle 12, force particle 5. This is the overall discussion. Clear everyone? Okay. I think you people have written everything. Fine. Now let me discuss literally the God particle or boson particle exist or not. But before it, I just want to tell you regarding the Higgs boson particles, about what the Peter Higgs and Satyennath Bose said. A man who firstly informed about the existence of God particle, his name was Professor Satyennath Bose. His name was Professor Satyendranath Bose. His name was Professor Satyendranath Bose. So Professor Satyendranath Bose was that person, guys, who firstly informed about the existence of God particle. Okay, existence of God particle. So Professor Satyendranath Bose firstly informed about the existence of God particle. But when this person, Satyendranath Bose, informed about the existence of God particle, many people did not understand what Satyendranath Bose wanted to describe. And that is the reason in the beginning when Satyendranath Bose informed about the God particle, people was not realized them. They were not ready to believe on them. After many years, what happened? After many years, what happened, guys? Another scientist, his name was Peter Higgs. Another scientist, his name was Peter Higgs. Okay, another name was Peter Higgs. Peter Higgs further described about the same concepts. Peter Higgs further described the same concept about the God particle. And Peter Higgs got so much popularity when he described about the God particle. Then other scientists said, okay, whatever you are telling, already earlier Professor Satyendranath Bose defined. Already what you are telling, Satyendranath Bose already defined. Okay, and this is the reason, guys, Professor Satyendranath Bose became popular as a father of God particle. Okay, so who is the cause as a father of God particle? So answer, remember, Professor Satyendra Bose. But because of these two scientists' contributions, okay, because of two scientists' contributions, everybody understood about the God particle. Because of these two scientists' contribution, everybody understood about the God particle, and this is the reason God particle started. People call them as a Higgs boson particle. The Higgs here is what? Feature Higgs, and Professor Satyendra Bose is the boson particles. Okay, wait here, guys. Okay, I just want to tell you, even Peter, he's got Nobel Prize, I think. Okay, but Professor Satyendra Bose never got the Nobel Prize because Nobel Prize have some rule. After death of a person, Nobel Prize not awarded. So when the Higgs, I think, got the Nobel Prize, it's not a very sure, but I thought, like, I found somewhere, guys. Listen, somewhere not written form. Okay. Satyendra Bose even died before that incident when the Nobel Prize was awarded, and this is the reason he not got. But Bharat Sarkar has given some of the very highest civilian award. The second highest civilian award, that's a Padma Vibhushan. The highest civilian award is a Bharat Ratna. The second highest civilian award is a Padma Vibhushan. Third highest civilian award is a Padma Bhushan, and the fourth one is a Padma Shri. Okay, Padma Shri. So in such a way, guys, these people got a prize and all. Actually, I'll go further about the discussion of some more about the Satyendra Bose contributions. But before it, I would like to tell you about what? About the God particle existence. Those experiments they perform. Which perform? Under sun experiment, European country perform. But the hypothesis and ideas of God particle was given by these two scientists. Understood or not? The hypothesis and ideas about the God particles, the theories of God particles, was given by the Satyendra Bose and Peter Higgs. Actually, in this entire experiment, somewhere I use a term about the hadron. Hadron, see, large hadron collider. What is the hadron? Hadron in the physics means if number of quarks are 2 or more than 2. If number of quarks are 2 or more than 2, then it is called as a hadron. The hadron consists of 2 or more than 2 number of quarks. Hadron consists of a 2 or more than 2 number of quarks. So I can tell you guys, proton is a hadron. As for example, neutron is a hadron. Why? Because proton and neutron have a 3 quarks. You remember or forget, guys? How many number of quarks inside the proton? 2 up quark, 1 down quark. I told you, guys. In this discussion, what you found? In this discussion, you already found proton have a 3 quarks, 2 up quark and 1 down quark. Neutron have a 3 quarks, 1 up quark and 1 quarks. And those have a 2 or more than 2 number of quarks. They are called hadron. So I can tell you proton and neutron is a hadron. Yes or no? I can tell as a proton and neutron are the hadron. Kindly remember. Clear, everyone? Ab now come here, guys. Okay, because in this discussion, somewhere hadron term is written. See here, guys. Somewhere hadron term is written. Okay, it means this is those colliders, last size of collider, where what is we are going to use? Hadron we are going to use. Hadron we are going to use means what we are going to use? Proton and neutron we are going to use. And what are inside the proton? You know here very well, guys. Proton have a presence of quarks and God particles. So if I'm going to take the proton means I'm going to take a hadron. Understood or not? If I'm going to take a proton means what I'm going to take? Hadron for the experiment. Now, how this experiment performs, just see a surface level, guys. Don't go in more and more detail, just see in the surface level. I think you people know very well E is equal to mc square. E is equal to mc square. Okay, Einstein energy law. E is equal to mc square. M is equal to mass here. E is equal to energy or potential. E is equal to what? Energy or potential. And C is equal to what? Speed. So E is equal to energy or potential, M is equal to mass, and C is equal to speed. Now see what happened, guys. Suppose this is the cap, this is a cap. A small size of cap is in my hand. Okay, here, guys. This is the cap in my hand. If I ask you what is the mass of this cap, you will tell, sir, it's very, very less. देखो गिर गया, इतना हल्का है ना? Why wow? What is the mass of this cap? 10 very, very less. Very, very less. Okay. If I throw this mass, है ना, तो this is my younger bro, है ना. But the speed of this cap I'm going to change. First time I'm going to throw this on this body, guys. Very slow speed. Okay. So if I'm going to throw this mass, the mass is very less. Okay, mass is very less. And what about the speed? Very less. If speed is very less, so what about energy? Very less. And this will not hit to this guy. Because this energy level is very low, na? Very small mass. I am slowly going to throw on his body. He will enjoy. Understood why he will enjoy? No problem, sir. But next time the same mass, but speed is changed. More faster speed here, guys. And more faster speed I throw this ball, guys, so the energy level is high. This time it will hit and have a pain. Understood? This time it will hit and have a pain. I think you can understand very well. If we are going to change the speed, the energy of potential level going to rise. If I'm going to make a constant mass, but changing the speed, so what about energy level? Increased. Clear? Now listen. Suppose these are 2 pens, guys, in my hand. Anybody see here? These are 2 pens, hai na? 2 pens. See experiment. These are 2 pens in my hand. Acha, see. These are 2 pens in my hand, hai na? These 2 pens I'm going to throw with certain speed. Speed is slow. Now with the slow speed, this pen is coming and do the collision. So slow speed se agar pen is doing the collision, so with slow energy they are doing the collision. Slow speed means slow energy. Yes, slow speed, slow energy. If this mass, 2 objects I'm going to throw with the slow speed, guys, and they're going to do collision, that will break into small pieces. Yes. I will decide, not you. It will break into small pieces. See experiment what I'm doing. Second time I'm going to increase the speed, and more speed the collision happens. See my expression, how much speed? More speed collision happen. With more speed when the collision happen, the more energy se collision happen. When more energy collision happen, it will break into small pieces. The more energy, more small to small character will come outside. I think you can understand very well. If this 2 pen, speed of light, I rotate fast. 3 lakh kilometers per second. So imagine how much energy is there. 3 lakh kilometers per second is speed. The energy level is very high. But now this pen is going to come in collision. What happened? Let me start. Small to 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 small. 3-4 months small to small to small. 1 year, 2 years, 3 years small to small. I'm telling you quantity 3 years past. Small to small to small. What kind of small particle what is made up by that will also come. Did you understand or not? Exactly. This level of experiment perform small to small, up to fundamental level, fundamental particle you are doing the study. So how much energy should be there to do the collision and all? Neither. How small to small fundamental God particle, boson particle you can study? Impossible. Yes. Tell yes, sir. Yes. And that is the reason, guys. This much of energy level is used there, guys. This much of energy level is used there. Okay. Now I'm going to show you all the entire experiment. Suppose this is the accelerator, and this is the first accelerator, guys. And the name of first accelerator is called as the cyclotron. What is that? Cyclotron. Try to understand. But again, I repeat, guys. UPSC will never go up to the experiment and all. Whenever you see the UPSC ask the question, it is based on the application of the experiment and all. So this is the collider. This is called a cyclotron. And what is here in the cyclotron? You see here, guys. It is a kind of superconducting magnet. So green color I made it. It is a superconducting magnet. What is it? Superconducting magnet. This is what? This is superconducting magnet. Okay, superconducting magnet. Now see, suppose this is the proton or hadron. What is that? Proton or hadron. This is proton Or I can tell you, you people know very well proton means hadron, both are same. Because proton and neutron are the example of hadrons. Okay. Every basic part try to understand, guys. Okay. Now see, when a proton is a positive charge, everybody know. When the proton is going inside the accelerator, and see this superconducting magnet, they will push the proton. So when they push the proton, proton speed increase, and everywhere the proton is going to push with that superconducting magnet, increase the speed, increase the speed, increase the speed, increase the speed. And here the energy level will go to the mega electron volt. It's the energy potential value I have written the units, mega electron volt energy go. Okay, now later on what happened? Now the next accelerator it will go. Next accelerator is bigger than cyclotron. See, more bigger than what? This is called synchrotron. Again, what is here, guys? Superconducting magnet. What is superconducting magnet? Push it. When they will push it, guys, what will happen here? Giga electron volt, and the value of giga electron volt will be less, but higher than the mega electron volt. After it, what happened, guys? After it, what happened? After it, I'll send it. We will send it to the next accelerator, and next accelerator is the biggest one. That is a 27 kilometer. You understood? What's the name of this? Large Hadron Collider. But remember, this is not only accelerator. This is also called as a collider. Okay, this is also called as a collider. There's a Large Hadron Collider, 27 kilometer length, and every of the collider, every of the accelerator, guys, accelerator. But it's not only accelerator. This is also collider. And here finally we maintain what? Speed of light. What about the speed we maintain? Speed of light. Speed of light. And see here, guys, what is this side? See, ELICE, ATLAS, CMS, LSCB. See, these are the various name of detectors. Okay, what happened here, guys? A proper strategy follow here, guys. What proper strategy? First of all, we maintain the speed of lights. The both protons, both hadron, they move with the speed of lights. And then when they maintain the speed of light, then they are coming and fusing together, and fusing together. Did you understand or not? They're fusing. And whenever they fuse, guys, with the massive speed. So see, the speed of light, the massive energy ke saath they are going to fuse it. And here the energy level is what? Very high. Giga electron volt, very high. Here electron volt less, here giga electron volt very high. And when the massive speed ke saath the collision happen, now small to size of particle will come. And definitely, guys, in this experiment, what happened? Guard particle reported. Those cameras are there, guys. These Atlas CMS, they're very powerful cameras. Within a millisecond, not even the second, within a millisecond, less than 1 second, guys, fraction of second, trillion photography they can take. Trillion photography they can take. If you imagine in this 27 kilometer of length, the guard particle, the proton is moving with the speed of light. So 27 kilometer of length. If any things are going to move with the speed of light 3 kilometers per second, so million trillion times they move inside. So million trillion times they fuse to inside also. Million trillion times if they are moving, the million trillion times the hadron will fuse together. Proton will fuse together, and they are capturing the picture images, trillion photography within fraction of second. In this photography, guys, guard particle was detected, and not only guard particle was detected, for a certain period of time, antimatter also developed. Antimatter also developed, and those antimatter I told you earlier, guys, it was detected here. It was detected here. Like a rough picture, you just make it, guys, but this picture is not important for examination. But overall, what the experiment performed, this is overall experiment. Just make a rough picture. How superconducting materials used in daily life? Which material? How to do? I'm telling you surface level experiment. Array is $1 billion experiment. Theoretically, I can tell you. I was not the part of sun experiment, no? So just I'm telling you. It's very complex structure. Okay, and see, this is somehow the structure that you can see here, like in this actual picture. Okay, in this picture you can see like CMS. Okay, it's very small. Upside is total, rocks, mountains, houses, etc. Okay, and this is the CMS here, the one lab. Oh, sorry, detector. This is here. Okay, Atlas is here. LIC is here. So those I told you it is LSC total 27 kilometer of length. Okay, upside is the total rock, mountains, houses, etc. The very research happened downside in the tunnel, guys. It's a surface view. Upside, what is there, guys? Okay, well, it's a rough picture that I wanted to show you. France is here. Swiss is here. So Swiss-France border. This is the area. This area, the border is what? Switzerland. And as a Switzerland. Okay, this is a Switzerland area. This is a France area. The Swiss-France border near Geneva. And nearby areas of Geneva. What? Madam, it's a safe area and Europe is going to develop. Resources are available. Okay, not only one reasons. Resources are also available. If they will develop in India, so they will carry all material to India is not possible. Right? Where the resources are available, better to perform the research there. Na? Why mining happen? Where the mining available? It's not a seismic zone, etc. Also, there are many factors are there. So the disturbance is not possible. Safe zone area.
No light.
Huh?
No light.
No, light white nahi. Light to you can make the deep inside the rock, so it's safe now. Okay, upside rock work area is also there. The more work as a barrier type. Okay, not only single factor, many factors are there. Okay. Actually, here one more discussion is very important. It's called Bose-Einstein statistics that you can call as a BS. And one more concept you can call as a Bose-Einstein condensate. Even when UPSC asks this question, many people even open their own mouth in the examination hall. Of course, the Bose-Einstein condensate, the question was not as like you people can solve, guys, very easily. If you not prepare properly this UPSC examination. The topic of discussion is the Bose-Einstein statistics and Bose-Einstein condensate. Okay, Bose-Einstein statistics and Bose-Einstein condensate. Actually, what is a Bose-Einstein condensate? Remember, guys, for the coming year, it is the most important topic every year for your paper. Okay, every year for your paper. What is the concept of Bose-Einstein condensate and Bose-Einstein statistics? Bose-Einstein condensate, I think you know what it is, a fifth state of matter. It is a fifth state of matter. It is what? It is a fifth state of matter. Okay, it is a fifth state of matter. Okay, it is a fifth state of matter. What is that? Bose-Einstein condensate. Okay, see here there is a two scientists name used. The one is a Professor Satyendranath Bose and second is the Albert Einstein. Okay, Albert Einstein. So Satyendranath Bose and Albert Einstein. What is the meaning of fifth state of matter? If you read the science in the 9th and 10th standard, yeah, by mistake you read the NCERT book. So you will get this like UPS, even in the book is mentioned there, solid, liquid, gas. These three of matters, so definitely it is mentioned inside your book. Fourth state of matter is called as a plasma. Fourth state of matter is called plasma, and fifth state of matter is already mentioned, that is called Bose-Einstein condensate. Okay, so what is the fifth state of matter that you can see is a Bose-Einstein condensate? First state, second state, third state, fourth state mentioned on board. So first state of matter, solid. Second state of matter, liquid. Third state of matter, gas. Fourth state of matter, plasma. Fifth state of matter is the Bose-Einstein condensate. Fifth state of matter is the Bose-Einstein condensate. Okay, fifth state of matter is the Bose-Einstein condensate. Now listen. Okay, listen guys. Acha, if you heat up solid particle, liquid, when you burn solid, it will convert into liquid? Yes or no? Further you burn liquid? Gas. Further you burn gas? Yes. Plasma is the ionized gases. Very good. Plasma is what? It is a ionized gases. That's why I want to tell you, and I want to tell you, please heat up, heat up, heat up. Solid heat up, liquid. Liquid burn, gas. Gas burn, ionized gases. Ionized gases, plasma. You know, within the sun, massive and massive temperature, everything there in the ionic form. That's why the sun is what? Plasma feature. Because the sun is what? Sun is the plasma feature. And what is the fifth state of matter? Bose-Einstein condensate. Definitely you may ask, sir, what is this matter? Because these matters are very easily to understand. See, UPSC question. 2018 mains paper. Many people open their own mouth in the examination hall. And by the way, particle phase is not a chapter also. Clear? Now let me complete. What is the Bose-Einstein? And see, the concept of Bose-Einstein condensate, etc. was given in 1924. The concept was given in 1924. So the concept of Bose-Einstein condensate was given in 1924. Actually, you know, Einstein is a very genius scientist. And those person even worked with the Einstein definitely was very genius. And Satyendra Bose were working with the Einstein. So in reality, I was telling you, our Indian scientist, Professor Satyendra Bose was also genius, a great physicist. And even I heard somewhere he was a mathematician also, but more popular as a physicist. Whom? Professor Satyendra Bose. And Satyendra Bose was actually under the core group member of Einstein team. Core group member, you know very well. Just like kitchen cabinet of government. The core group member of Einstein, okay, Satyendra Bose were working with them, with that team. Okay, and this Satyendra Bose has given such idea about what? This fifth state of matter. And he talked to Einstein, because in that time only Einstein was that much of genius with whom even Satyendra Bose wanted to discuss with him. Now this Bose-Einstein, finally with the discussion of that, both two scientists brought one of the conclusions about the fifth state of matters. Okay, but the first ideas of the fifth state of matter was given by Satyendra Bose. But discussed, proved in that time very intelligent scientist was only Einstein. You know, Einstein was that much of genius scientist, guys, not believe. With the 20th century was going to complete. 1999, 1998, 1999, 2000 complete. Then Times magazine, very popular magazine, international level magazine, wanted to give a name of a person, century of the year. Century of the year. Which person we should have to give rewards, awards, popularity? So Times magazine have done the survey, and many people said like US president, yeah. Somebody may said like Hitler. I'm creating something. Somebody said like Napoleon. Somebody said Mahatma Gandhi ji. Well, many. Okay. So, many opinion was there. This person. But finally, in that magazine, you know which person photograph was on the cover? Albert Einstein. Because the people know very well, guys, the coming generation is a science generation. Coming generation is a science generation. There is so much of political leaders, very popular people, rich people. No, not even any people. Those got the award of the Time magazines of the Century of the Year award. And on the Times magazine cover was the Einstein. So Einstein has created that much of impact in the scientist community. On that behalf of that, scientist community has done a lot of experiment. Still, the lot of experiment is going on. Even see, James Webb telescope. You remember James Webb telescope? Those captured some images. They find out about the information about the Einstein ring. Those concept was given by Einstein. And you know when Einstein has done their own work and all, 1905, 1915. And today, in which year you are listening my classes? See, more than 110 years passed. Yes or no? And Einstein is giving you the idea about 110 years back, more than 110 years back, what happened in the Brahman. Understood? Neither Einstein visited there, nor you visited. But what about Einstein said? Today, with the help of experiment, you try to prove, and finally you got what about Einstein said? Everything was right. So 110, 15 years back, guys, those phenomena and the hypothesis, the concept of Einstein was given. Today, you are going to prove because you earn money, you have a research and development, you can set up the laboratory, and you can search them. So how much the genius that scientist was? Not understood. Are you understood or not?
Yes, sir.
I'm not praising you, I'm praising the Einstein. So with that Einstein, our scientist, Indian scientist, Professor Satyendrath Bose, and because of these two conclusions, okay, what happened, guys? Finally, what happened? Bose-Einstein condensate detected, identified. Now you may ask, sir, tell me what is Bose-Einstein statistics? See, guys, what is the Bose-Einstein statistics? See, guys. Okay, do one thing. Listen me carefully. Here I will do some dictation also. 3-4 minutes. I'll do dictation, but first you try to listen, guys. Any matter you take, in any matter, any particle you take, any matter, any particle you take, in any condition, at any condition, not matter. So any of the particles, any of the matter, any of the conditions. Okay, if you are going to take them, if you are going to keep them, in near to absolute zero, What is absolute zero? What about the minimum temperature of Brahman? Minus 273 degrees Celsius. And this is the minimum temperature of the Brahman. What about minimum temperature of Brahman? Can go 0 Kelvin or minus 273 degrees Celsius. I spoke to you earlier, guys. Okay. So if you keep this any of the matter in the near to absolute zero, minus 273 degrees Celsius, I'm going to keep minus 250, minus 243, minus 2, near to. I'm not telling exactly. Okay, so behavior of all the particles are going to change and come in single behavior. And they come in single behavior. And those single behavior particles they are going to form, this is called as a boson. And this boson is what? This is a fifth state of matter that we are calling as a Bose-Einstein condensate. Okay, those boson particle is going to form. This is called as Bose-Einstein condensate. So again I repeat. Any conditions, solid, liquid, gas, plasma, anything, any form is available. When we are going to keep them in nearby absolute zero temperature, they all is going to come in the uniform condition, and that uniform condition, those form, this is called boson. And this boson condition that is going to form, technically called as Bose-Einstein condensate, because everything condensed. Right, low temperature, the things are going to condense, they are going to be expand. Low temperature, where things are going to condense. High temperature, where it's going to expand. So what about the condition they're going to expand? Form a uniformity structure that is called boson, and this feature is called as a Bose-Einstein condensate, and this Bose-Einstein condensate is the fifth state of matter. Understood? Write this statement. I told you it is some technical part, you just write. An extremely cold temperature, right? An extremely cold temperature close to absolute zero. It is mentioned in page number 439, guys. Okay, I mentioned this all the concept in the page 439 that I'm dictating a few lines. Okay, Bose-Einstein condensate, fifth state of matter, and Bose-Einstein statistics. Okay, at extremely cold temperature, close to absolute zero, all particles in a system come together. All particles in a system come together into a single state. STAT, into a single state. known as into a single state known as Bose-Einstein condensate. Known as Bose-Einstein condensate. You know very well, this is considered as a fifth state of matter. Okay, this is considered as a fifth state of matter. This idea was first proposed in 1924. Okay, this idea was first proposed in 1924. But the technology at that time, but the technology at that time could not reach such low temperature, could not reach such low temperatures needed to test it. Because that much of low temperature was not possible to develop in 1924 for entire experiment. Those statements I'm telling you. Clear everyone? To test it. You know, after 70 years, another scientist in 1995, they have further given the same statement. And even not this time, they have given the statement. They will prove it through the law of certain experiment. So experimentally, what about the Bose-Einstein is telling you, it proved in 1995. Okay, whatever this Satyam Bose and all they are telling guys, okay, in 1925. In 1925, what they have given the statement, guys, in 70 years later on, 1995. In 1995, there's few scientists. The name was Eric Cornell, and one more scientist. Even the name of the person is not required for you guys. Carl Wieman. Okay, Carl Wieman. Eric Cornell and Carl Wieman. Okay, they successfully created the Bose-Einstein condensate using a small group of some atoms at very low temperature, absolute zero temperature. So finally, whatever the 1925, this Bose-Einstein even spoken there guys about the Bose-Einstein condensate practically developed after 70 years in 1995. Did you understand or not? Practically it proved in the 1995. Okay, even these people, even some other people got a Nobel Prize for this work also. Fine. So this is just a theory. And this is the first experimentally proved Bose-Einstein condensate. Clear. Now you may ask, what is the Bose-Einstein statistics? A Bose-Einstein condensate, you people very clear? Yes. Understood? Now you may ask, sir, what is the Bose-Einstein condensate? Statistics. Actually, statistics term is used for the behavioral activities. Okay, statistic term means it is what? It's a behavioral activities. In very simple statement, I can tell you guys, behavioral activity of Bose-Einstein condensate is considered under the Bose-Einstein statistics. Write the statement. Behavioral activity of Bose-Einstein condensate. Bose-Einstein condensate means fifth state of matter, right? Behavioral activity of Bose-Einstein condensate, BEC. Behavioral activity of Bose-Einstein condensate. Behavioral activity of Bose-Einstein condensate. So behavioral activity of Bose-Einstein condensate is considered under BES. Is considered under BES. It revolutionized the field of physics in three ways. But it brought revolution in physics in three ways. It revolutionized the field of physics in three ways. One, improve the benchmark in terms of particle physics model. Okay, second point. Let the foundation, LAID, right? Let the foundation of God particle. Let the foundation of God particle. Let the foundation of God particle and help Peter Higgs and helped Peter Higgs and helped Peter Higgs in winning a Nobel Prize. In winning a Nobel Prize. I told you guys the Peter Higgs got the Nobel Prize. Okay, but not the Professor Satyenadu. Reason I told you why. Okay, third point. Enhance the benchmark. Enhance the benchmark. Enhance the benchmark of a standard model of particle physics. Of a standard model of particle physics. So enhance the benchmark of a standard model of particle physics.
Sir, first or third का difference है? First or third का difference है?
Standard model and particle physics.
Like
Particle physics is a broad perspective. A standard model is in the favor of only, what happened?
it is there.
Fine. So this is the overall about the Bose-Einstein condensate and Bose-Einstein statistics. And Bose-Einstein statistics was UPSC question in your paper. Can't remember. Even if you check your question paper, guys, around 3 questions. Around 3 questions. UPSC asked from CERN, God particle, such kind of. I'm telling prelims paper. 3 questions. Now, come toward the next topic, that is neutrinos. So, give a next heading, neutrinos. Next heading is the neutrinos, right? So, next heading is what? Neutrinos. I still remember, guys, first time when whenever I have seen about the neutrinos, so what is stuck in my mind, do you know? Pata nahi, it is going to strike in your mind or not. You are listening me?
Yes, sir.
Are you sure?
Yes, sir.
You are looking very tired. Give your smile. type wala nahi. Decent smile. Not like a different type wala. Okay, name I cannot use. It's not Roman and Cons type, okay? Give an innocent type wala smile. Cute. Ab now come. Actually, when I found the neutrinos first time, see, what I recall in my mind, the name is looking like very close to neutron. You also recall or not? So better we start from that same discussion. Those I have generated in my mind, I want you also generate because you are my student. Okay? Yes. So here I am going to discuss with you one about neutron versus neutrinos. And just 2-line discussion, guys. Just 2-line discussion, guys. Not more. 1 line and 2 line. Finished. Okay. 1 line and 2 line. Then finished. So one side neutron and second side neutrinos. Neutron versus neutrinos. Okay. Right. One side neutron, second side neutrinos. Neutron versus neutrinos. See, how to describe the neutron and neutrinos? See, guys. Neutrons, actually, they have mass. Neutron have mass? But neutrons are those which have no charges. Neutron have mass, but they have no charges. Okay, the neutron have mass, but they have no charge. Charges means plus, minus type. Yes, sir, I know very well. Proton is the mass, positive charge. Electron is the mass, negative charge. Neutron have a mass, no charge. Chemistry? Okay. But what about neutrinos? Actually, neutrinos in the beginning described as these are those fundamental particles which are massless and chargeless. Now you may have a question. Sir, just few time back during discussion of God particle, you told me without mass, nothing exists. So either you are wrong there, or you are wrong here. See, Neither I was wrong there, nor I am here. I am your teacher, trust me. I'm telling you, in the beginning, when the neutrinos defined, then they defined as a massless and chargeless fundamental particle. In the beginning, today I'm not telling you. Today, in the last, I will tell you in the conclusion what about neutrinos, but you write the statement in the beginning about neutrinos. In the beginning, copy and pen, right? Don't be lazy, okay, right? No respect, right? In the beginning, but after. In the beginning, neutrinos defined as, because beginning term is very important here this time. I mean, the last you understood why I'm dictating this statement. Otherwise, I will never force you, right? In the beginning, and online people, those are listening on YouTube, right? Right? You also feel, free mein agar you are getting something, free have no value, everybody know very well. But okay, you write. By YouTube mein, those, you tell. Those free YouTube mein videos online is coming. The quality of free wala and the quality of class wala is same or different? How much different? This much different or this much different? This much different. Thank God you understood. Thank God you understood, na? Physical and front of teacher wala class and YouTube on live us tarah wala class have a massive difference. This is the actual real class that is going to come on YouTube. And those people are telling you, na, YouTube original class. What? Actually, it not. Current affairs every time change, but static part not available. Current part what? Everything will change. Or science attack mein what? Next time I will change. By time change, research change, I will change. History mein Babar will not change. Mahatma Gandhi, 1947, India got independent. From last 30 years, people are doing the same. Understood or not? But science attack mein, you see, what we have started to, just maybe Gaganyaan said, just in the coming future, yes or no? Yes. So in the beginning, neutrinos defined as massless and chargeless fundamental particle, right? Neutrinos defined as a massless and chargeless fundamental particle. In the beginning, neutrinos defined as a massless and chargeless fundamental particle. Massless and chargeless. 𝐶𝐸 इतनी देर में तो मैं लिख दिया होता बोर्ड पे 3 बार, है ना? Massless, बेटा लिख लिए? Massless, chargeless, fundamental. Very good. You always be here, है ना? Support me, है ना? You are very important. Those people not supporting me, go back, last row. अब now हो गया. Come. Origin of neutrinos. Give another heading. Origin of neutrinos. 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 What about the origin of neutrinos? Actually, guys, in the beginning, what about the origin of neutrinos? Actually, scientists believe the first origin of neutrinos happened just after Big Bang. So the first time neutrinos originated when? Your pronunciation should be correct. Just after Big Bang. हो गया. Very good. Again, sir. Okay, just after Big Bang. Okay. Just after Big Bang. Okay. Just after Big Bang. Okay. It means just around 13.6 billion years later on, when the Big Bang happened. It's after just few time. Okay. Just this is the first origin of neutrinos that scientists believe. Okay. If I ask you guys about the today's origin, only in that time neutrinos originated, and still today originate. Yes, today's origin of neutrinos are also here, guys, and many reasons of today's origin. I can give you here examples. So today's origin of neutrinos. Supernova explosion. Gamma ray burst. gamma ray burst. Okay, supernova explosion, gamma ray burst. Stars, guys, stars, etc. So, sorry, stars are also a reason behind the generation of neutrinos. Yes, stars are also generating the neutrinos. Stars are also generating neutrinos. So, stars are also generating neutrinos. Clear, everyone? Fine. Stars are also generating neutrinos. Even I just want to tell you, a supernova explosion is what? Death of star. When you will listen about the star life cycle, guys. Okay. So in the star life cycle, my one topic is there about the supernova phase. Okay, supernova phase is the death phase of star. Supernova phase is the death phase of star. Even if you go on page number 429, okay, page number 429, 8th edition that I have right now. Okay, here life cycle of a star is mentioned inside your book. Life cycle of a star is mentioned inside your book. देखो, इसमें I mentioned there what is the life cycle of stars and what is the supernova phase. Okay, what is the supernova phase? You can see here. Okay, how the star is going to form from the beginning phase of a star is called as a nebula. Okay, the star origin is from nebula, and a star death is called supernova. And when the supernova means the star is going to die, it is mentioned at page number 429. When the star is going to die, guys, stars generate massive heat and radiations. Listen me, guys. When the star is going to die, this phase is called supernova phase. They create massive heat and radiations. And in this heat and radiations, when neutrinos also there, guys. And very interesting statement. Death of a star is called origin of new star.
Wow.
Means that one of the star is going to die now, so parallelly one of the other star is going to form. So death of a star is what? Is the reason behind the origin of new star. Very beautiful statement I'm telling you. Okay, so supernova explosion, in such cases neutrinos also generated. Gamma ray burst, actually such kind of phenomena also happen in the Brahmand. Many activities happen. Long back, gamma ray burst, I made some video also. In that time, there was some incidents. Very beautiful images going to form in the Brahmand. Gamma ray burst. They also even the reason behind it. So gamma rays are coming. They are going to burst there somewhere, and they are creating some of the neutrons also in the Brahmand. Those are coming towards us. And stars, so very well, guys. Sun is a very common, guys. Sun is what? Sun is a stars. Sun is a what? Stars. So now you can understand very well, guys. There are so many reasons in the Brahmand. They are the reason behind the generation of neutrinos. And which star is the closest from Earth? Sun. So massive neutrinos, those our Earth is going to receive. This source is the Sun. If anybody this kind of question will come, guys. What is the main source of neutrinos on the planet Earth? The answer is the Sun. Write one statement anywhere. Sun is the main source of neutrinos on the planet Earth. Sun is the main source of neutrinos on the planet Earth. Okay, Sun is the main source of neutrinos on the planet Earth. Oh. Sun is the main source of neutrinos on the planet Earth. Sun is the main source of neutrinos on Sun is the main source of neutrinos on the planet Earth. Everybody clear? Now you may ask a question, sir. So neutrinos are coming towards us. Yes. So sir, neutrinos are penetrating our body. Yes. But they are not dangerous to you. I read some article, guys. In that article was written within a fraction of second. Again, fraction of second. Less than 1 second. Fraction means less than 1. Some part of second means very less than 1. Okay. Within a fraction of second, millions to trillions of the neutrinos are passing from human body without creating any harmful effect. Passing from human body, my God, without creating any harmful effect. Wow, good. Actually, you don't feel, you just write only. You write. नहीं कुछ नहीं, आप don't tell wow. नहीं कुछ नहीं, right? Within a fraction of second, boring people, है ना? Right. I wanted to create interest in the topic, very intelligent topic I'm teaching you, and they are not try to be intelligent here. Within a fraction of second, right? Within a fraction of second, trillions of neutrinos are passing from human body. Within a fraction of second, trillions of neutrinos are passing from human body. Trillions of neutrinos are passing from human body without creating any harmful effect. Without creating any harmful effect. Okay, without creating any harmful effect. Control your feelings. So without creating any harmful effect. Okay, next point. Okay, up now I'll want to tell you here. Even artificially we can also generate neutrinos. See here guys. Artificially we can also generate neutrinos. So is it like we can also develop neutrinos artificially? Answer is yes. So artificially we can also generate neutrinos or not? Yes. Okay, artificial neutrinos can also generate. Even guys, a long back, one of the person was Wolfgang Pauli. Wolfgang Pauli. He has generated neutrinos from gamma rays. He has generated neutrinos from gamma rays. It means with the help of some artificial procedure, some artificial technology, we can also generate neutrinos. Very simple guys. Microwave radio waves, they are coming under the solar radiation. Yes, I know. Yes. Neutrinos are also under solar radiations, under sunlight. But microwave radio waves we can generate artificially in your mobile phone or not. Tabhi to you people call to anyone, guys. Arey, in my mobile phone when I'm calling you, so from my mobile phone what will generate? Radio wave generate. So I also have developed the technology that generate the radio waves or not. Yes. And then we can connect from tower to tower, and then the call you will receive. It's a natural, yeah, it's artificial. And then we people are connecting with the mobile phone. How the satellite to our signal is coming? Artificial radio waves. Understood? The same thing I am telling you in this case, guys. We can also develop neutrinos artificially. Because I am going to discuss with you about neutrinos applications. Agar artificial neutrinos you develop, tab to neutrinos you can utilize in your life for many purposes. Yes. So I am telling you artificial neutrinos can be also developed. And when artificially we can develop, so we can utilize the neutrinos in our life. I'm now coming to the application of neutrinos. Now come application of neutrinos. Now come into application of neutrinos. So application of neutrinos. So come into neutrinos applications. What will come here, guys? See. Actually, as a scientist's opinion, it may bring revolution. It may bring revolution in information and communication technology. One, it may bring revolution in information and communication technology. One, it may bring revolution in information and communication technology. So it may bring revolution in information and communication technology. Definitely, guys, the signals, waves, etc., they will not loss. Okay, there will be better and better response. The communication information quality was much more better here. Second one, bring revolution in medical sector. Bring revolution in medical sector. Okay, in various kind of diagnostic work, I can use the neutrinos. They are passing from your body very easily. So various kind of diagnostic work I can use very easily, guys. X-ray, okay, MRI. You know, many features if I want to check inside your body with the help of neutrinos we can do, and they are not harmful also. Not even the radiation kind of impacts. Okay, in the case of X-ray, gamma, you know, some problem happened to your body, guys. But in this case, I have no problem. Diagnostic work. Even neutrinos you can use in the case of what? Mysteries. Mysteries. Better right. Mysteries. In the understanding of mysteries of universe. They will be also helpful in the understanding of mysteries of universe. They will also be helpful in the what? Mysteries of universe. So they are also helpful in the understanding of mysteries of universe. So they are also helpful in understanding of mysteries of universe. Now you may ask, what kind of mysteries, guys? Very simple. Dark matter, right? Dark matter. Dark energy. Yes, sir, you spoken earlier. Dark matter, dark energy, mostly not known. Parents, dark matter. Bhavi, dark energy. Very good, very good. You people remember? Excellent, excellent, excellent. Dark matter, even black hole, etc. These all are the part of what? These all are the part of mysteries. Just like those ideas of dark matter, dark energy is still not clear, guys. That we can get here very easily. Black hole. Next one, guys. Even the neutrinos are also helpful in this geoneutrinos. Fourth application of neutrinos, I am telling you in the reference of geo. Geo means earth or rock. Geo means what? Earth or rock. Geoneutrinos. Actually, neutrinos can penetrate the rock, guys, and can go deep in the rock. Okay, so it means neutrino study is also useful in the study of deep in the rock. So neutrinos can go deep in the rock, right? Neutrinos can go deep in the rock. Right, neutrinos can go deep in the rock. So neutrinos can go deep in the rock. Okay, neutrinos can go deep in the rock. Okay, definitely neutrinos can go deep in the rock. So within the rock, what kind of conditions, what kind of features are there? We can do their own study, guys. Not understood? How these type of studies are useful for us? Actually, guys, within the earth, those resources are available. So earth-based resources studies become easy here, guys. Earth-based resources studies. Earth-based resources studies. The one is what? Earth-based resources studies. So you may ask, sir, what kind of resources? Very simple, guys. Fossil fuels, mineral explorations. Fossil fuel like petrol, natural gases, mineral exploration work. Mineral exploration work. Mineral exploration work. Mineral exploration work, this kind of studies. Even see, guys, with the help of geoneutrinos, we can see deep inside the rock. We can see the deep inside the rock. Okay, we can do the deep inside the rock and do that study of what? Heat conventional current. Heat conventional current. We can do the study of heat conventional current. What is the meaning of heat conventional current? Actually, inside the rock, guys, those massive and massive heat are traveling. Okay, massive and massive heat, those are traveling inside the rock. Sometimes, the heat formation inside the rock increases. Because some reductive elements, they suddenly increase their own activities, nuclear fission and all. And because of it, what happened, guys? Geothermal energy, natural heat inside the earth. Sometimes the heat increases because of many reasons. Okay, and whenever the massive and massive heat increases, guys, they are creating the massive pressure on the plates. Movement of plates start and having appearance of the earthquake. Understood or not? So I just want to tell you guys, through the help of these heat conventional current, okay, we can detect about the appearance of earthquake in a particular area. So that suspect, doubts and information like in the particular area about the earthquake and all, we can check there. Like, okay, we can do study of a heat conventional current and detect appearance of earthquake, right? And detect appearance of earthquake in a particular area. And detect appearance of earthquake in a particular area. And detect appearance of earthquake in a particular area. Okay, and detect appearance of earthquake in a particular area. Clear? Detect appearance of earthquake in a particular area. I think you understood very well, guys. There are so many applications, and most of the important experiments, those who are possible, I discuss with you. Clear? Okay. Now coming to some miscellaneous topic that is connecting with the neutrinos. The one is called as the ice cube. The one is the ice cube. First you come into the ice cube, then I'll go toward discussion of INO, and then I'll discuss with you about the concept of Neutrino oscillation. And then I'll tell you about the experiment of Neutrino oscillation. Okay, so three more concepts, even informations are connecting with the neutrinos are important. The one is the ice cube, second is the INO, and third is the Neutrino oscillation. So let me start first ice cube. Ice cube. What is the ice cube? Actually, guys, this is the world's largest neutrino observatory. What is ice cube? It is the world's largest neutrino observatory. This is what? World's largest neutrino observatory. This is what? World's largest neutrino observatory. Okay, तो दुनिया का सबसे बड़ा बिगेस्ट न्यूट्रिनो ऑब्जर्वेटरी कहाँ है? अजीब हालत है. I am asking something different, they are giving answer something अलग. What's largest neutrino observatory is towards the South Pole region. South Pole region. South Pole means towards Antarctica. Towards Antarctica. World's largest neutrino observatory is where? Towards Antarctica. It is located towards Antarctica. Okay, it is located towards the Antarctica. Our question is why it is called ice cube. Even it is spread in 1 cubic kilometer area. Spread in 1 cubic kilometer area. Right? It is spread in 1 cubic kilometer area and surrounded by thick sheet of ice. Of course, guys, it's a polar region, the massive ice will be there. But South Pole, it is spread in 1 cubic kilometer area surrounded by thick sheet of ice. And in this area have presence of telescope, ice cube telescope. And with the help of telescope in that area, they try to do the study of neutrinos. Those neutrinos are coming there, guys. They are trying to do the study of them. Okay, they are trying to do study of neutrinos there. It's the world's largest neutrino observatory, those set up for the study and understanding of neutrinos. So for study and understanding of neutrinos, kindly remember. Clear? So for studies and understanding of neutrinos. This is the important one, and once UPSC already asked in your paper about the ice cube. I can show you this picture also, guys. See, ice cube neutrino observatory, many picture you can see here, guys. Okay, ice and ice. Actually, this is the best picture that you can see here. Okay, so it's a deep inside. It's a deep inside. Only little bit information above you can see. Now the maximum areas are deep inside. Inside, what is the picture you can see here, guys? Inside, what is the picture you can see this? Okay. Okay, what? Okay, wow. It's a actual structure of ice cube, and don't go into the ice cube array. What is strings? Ice top, ice cube lab. A very cubic kilometer area, guys. Cube shape and in kilometer cube. Cube shape, kilometer cube. You understood? Cube shape, kilometer area. Shape is like cube shape. That's why it's called 1 cubic kilometer area. Did you understand? Okay, so there's just two pictures that show you guys. And see, lab is this upper side. Here, see, lab is, my God. All experiment inside. See, bedrock, down side. Deep. Okay, deep. What is INO? ION is an Indian Neutrino Observatory, right? ION is what? Indian Neutrino Observatory. Indian Neutrino Observatory. This is what? Indian Neutrino Observatory. So what is INO? Indian Neutrino Observatory. ION is what? Indian Neutrino Observatory. So it's a neutrino observatory. Those India is going to develop. So sir, it is still not developed. No, it is in developing phase. And where India is going to set up it, guys? Theni district, Tamil Nadu. Theni district, Tamil Nadu. Theni district, Tamil Nadu is that place, guys, where India is going to install the INOs. Where India is going to install INO. INO means Indian Neutrino Observatory. So India is going to set up a observatory in Theni district, Tamil Nadu. Neutrino INO. And see, why this area? Okay, here I'll show you a picture. Because it is located deeply inside the rock. Because it is located deeply inside the rock. Okay, see this picture. See, Indian Neutrino Observatory. See this picture. So India to get its own high neutrino observatory. Some name is coming now. Better you see this. Actually, this is a rock, and this is the depth. So actually, this neutrino is going to set up observatory deeply inside the rock, in this area of Theni district. And with the help of tunnel, people can come inside for the experiment. Now you may ask, sir, why this area? Why this rock is deeply inside? The reason is very simple, guys. If any of the radiations are coming, every radiation after some depth they will stop. But the neutrino can reach only. When neutrino have no problem, they can go deep inside the rock or not. Or in this classroom, those I'm taking your classes, those people are listening my online classes right now. Yeah, whenever they will listen. Okay, neutrinos are coming inside your room also. There is a wall, na? Solid objects, a rock can go to solid objects and not come.
Yes, sir.
So, sir, neutrinos are coming on my body right now.
Yes, sir.
Very good. Sir, but not dangerous.
Yes, sir.
Very good. Not dangerous, very, very good. Okay, but neutrinos have many revolutions possible in the coming future. Very, very, very good. Understood or not? Now next, very, 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 very good, I will not tell you. Okay, it's enough. So I think you understood why the neutrino observatory deep inside the rock. Any of the electromagnetic waves are coming. They will stop after some days, X-ray, gamma, micro-radio, but neutrino can reach. Did you understand? Okay, fine. Now the one that is called the concept of neutrino oscillation. Actually, neutrino oscillation is one of the experiments those happen. And this experiment even opened eyes of all the scientist communities. What eye even open, guys, I'll tell you. Reason those earlier people have discussed. What earlier people have discussed? Neutrinos are those which have a massless and chargeless fundamental particles. Did you understand or not? Yes. Through the help of neutrino oscillation experiment. Okay, for neutrino oscillation experiment, guys. See. In 2015, two scientists got Nobel Prize. Which Nobel Prize? Physics Nobel Prize. What was the name of the person, guys? 𝐃𝐸𝐧𝐢𝐧𝐠 and Arthur B. MacDonald. See, Arthur B. MacDonald. One is of Japan scientist, second is a Canada scientist. In 2015, Physics Nobel Prize was awarded to 𝐃𝐸𝐧𝐢𝐧𝐠 and Arthur B. MacDonald. Purpose, neutrino oscillation experiment. Purpose was what? Neutrino oscillation experiment. In this neutrino oscillation experiment, they proved. I'm not going to enter into the neutrino oscillation. I'm just telling you about the informations. Under neutrino oscillation experiment, it was proved neutrinos are chargeless. It's okay, but neutrinos have tiny masses. Okay, because even different types of neutrinos are coming towards the Earth whenever they were coming, and they have a different name also, V, Y, O. And whenever they were coming, guys, they are going to do collision also. And in between the massive and massive neutrinos, losses also happen. It means neutrinos have some mass and energy, neither how they lost. Did you understand? So some experiment, that's something I just given you some superficial type, okay, performed by these two scientists, guys. And for that purpose, in 2015 Nobel Prize of Physics, they awarded. So right statement. 2015 Physics Nobel Prize. 2015 Physics Nobel Prize were awarded. 2015 Physics Nobel Prize were awarded. 2015 Physics Nobel Prize were awarded to 𝐃𝐸𝐾𝐨𝐰𝐧𝐥𝐸𝐧𝐠 and Arthur B. MacDonald, to 𝐃𝐸𝐾𝐨𝐰𝐧𝐥𝐸𝐧𝐠 and Arthur B. MacDonald, 𝐃𝐸𝐾𝐨𝐼𝐧𝐥𝐸𝐧𝐠 and Arthur B. MacDonald for the study on neutrino oscillation. And they found, for the study on neutrino oscillation, and they found, for the study of neutrino oscillation, and they found neutrinos are massless, neutrinos are chargeless, but they have tiny masses. Neutrinos are chargeless, but they have tiny masses. Neutrinos are chargeless, but this is the information I'm telling you, kindly remember. Neutrinos are chargeless, but they have tiny masses. So this is the overall about neutrinos. Okay, this is the overall about neutrinos. So next topic of heading, gravitational waves. Me too. Me too.
Class 131.
Paka. Anyway, should be good. Food. Biryani. You asking which shop? I said whichever you good. Better. Better. Good. So tell na jaake Brahma. Chicken. Go and tell na one time. Message. Two people are telling. Go and tell Brahma fast. Ravi is telling that. Go. So go tell na. He will be anywhere. Go. Online na.
Don't come here.
Online.
It is in Hyderabad. Shagos is far from it. It's now 40. My biryani is special.
They will give. Respect me. Respect me. Okay. Now come next topic, gravitational waves. Okay, a wonderful topic, and I hope you people will enjoy more. I hope. Okay. Me too. Very good. But girls, what you people are doing? Are you listening me?
Yes.
Okay. Madam, take photograph with me also. Take photograph with me also. No, I'm just telling madam, don't be busy in phone, okay? And sir, you too. Up come here, respect me. Okay? Actually, for the understanding of gravitational waves, first of all, I'll go to a discussion of Einstein. Why Einstein? Because Einstein was that first person who informed about existence of gravitational wave. Did you understand? I discuss Einstein only here, guys, not any other places. Einstein name I use many places. Abhi just like listen earlier you have seen in the case of Bose-Einstein statistics. Einstein was also there. So I just want to tell you in the case of gravitational waves. Okay, before it you should have to go toward the discussion of Einstein. And two theories of Einstein I'll explain, and one of the theory of Einstein was UPSC question even 2018. Einstein special theory of relativity. Einstein's special theory of relativity. Einstein's special theory of relativity. This theory Einstein was propounded in 1905. This theory published in 1905, Einstein's special theory of relativity. So Einstein's special theory of relativity published in 1905. But Einstein has done certain mistake here, guys, in this theory. Einstein has done certain mistake in this theory. Those published in 1905. Another theory published, guys, Einstein general theory of relativity. And this Einstein general theory of relativity was published in 1915. So it was published in 1915. So first of all, I'll tell you what about the mistake those Einstein has done in their own special theory of relativity. Okay, Einstein said, like, in this Brahmand, everything fixed. Everything fixed, as it is there, it is there. Nothing are going to change here, guys. So write one statement under the special theory of relativity. Everything are fixed in the nature. In a very simple word, guys. If you go in detail, so in different way you can describe the concept of special theory. But I do not like to discuss the special theory. I want to switch toward the general theory actually. Everything are fixed in the nature. So special theory of relativity. Everything are fixed in the nature. So everything are fixed in the nature. If everything are fixed in the nature, so definitely you can understand very well. Nothing are going to change. You tell me, guys, we are in this world, in this nature, in this universe, where everything are fixed. No, sir. This time day, after some time night happen. Solar radiation change, sir. Effect of monsoon, day and night, rotation of earth, revolution of sun rotation, everything, the cosmic, everything is going to change, guys. So you understood very well, guys. Einstein has done some mistake. Understood or not? Einstein had done certain mistake. And that is the reason to improve their own mistake and all, another theory brought. And what is another theory? General theory of relativity. After 10 years, guys, this paper published, and his paper, this theory was there, general theory of relativity. Published in 1915. 14 made the theory brought, but published in 15, officially the year is 15. And what Einstein said in the general theory of relativity, everything are going to change with the respect of time, right? Means relative happen, right? Everything is all going to change with the respect of time. Everything are going to change with respect of time. Everything are going to change with respect of time. So everything are going to change with respect of time. Everything are going to change with respect of time. So everything are going to change with respect of time. Nothing fixed in the nature, guys. Okay, now in the general theory of relativity, he has given a lot of other statements. And these all the points, right? The points of general theory of relativity, those Einstein said. What about the point? See here, guys. First, universe is a space-time. Universe is a space-time. Matter wraps in its surrounding. Matter wraps in its surrounding. Matter wraps in its surrounding. Matter wraps in its surroundings. Universe is a space-time. Matter wraps in its surrounding. Okay, matter wraps in its surrounding. I'll explain everything. Wait, guys. Second point. Universe is constantly expanding. Universe is constantly expanding. Universe is constantly expanding. Second point. Universe is constantly expanding. Okay, so universe is constantly expanding. Second point. Third point. So universe is constantly expanding. If two different mass of object, right? If two different mass of object If two different mass of object fall down, if two different mass of object fall down, if two different mass of object fall down, so they will reach on same time in space. So they will reach on same time in space. If two different mass of object fall down, by the way, this concept was given by Galileo, but some of the scientists believe like, okay, write it, not worry. We are UPSC in nature 1, 2, 3, 4. Okay, if two different mass of object fall down, they will reach on same time in the space. The reason space is what? Vacuum. The mass here not matter in that cases. Okay, remember, third point. Fourth point. Light bends due to effect of gravity. Light bends due to effect of gravity. Light bends due to effect of gravity. So light bends due to effect of gravity. Light bends due to effect of gravity. Up here in the case of light bends due to effect of gravity have many phenomena. A, B, C. A, B, C. Because of this reason, many phenomena are going to be happen in the nature. What? A, right? Apparent position of a star is different. Apparent position of a star is different. Apparent position of a star is different from actual position of a star. Apparent position of a star is different from actual position of a star. It means those stars you people see in the sky, guys, in night. Okay, actually stars are not there. And after every time you feel like star is going to change somewhere their own position also. Okay, these all are because of this reason. I'll explain everything, guys. Wait. And this was the UPSC question, even 2018. This was the question UPSC asked. People told it is a current affairs. I said, Bekoof. It was a 1915 general theory of relativity was given. It is a always important topic. After 103 years, this question came in the current affairs question. But 103 years old current affairs question UPSC asked. But those people are telling science and current affairs for them. So you already know very well, no, sir. 70%, 60%, 70% the static is the science and tech. 30-40% what is coming in this UPSC always asked. And by the way, if you want to solve any of the current affairs, so without that static recipe you cannot understand what is there. Okay, fine. So apparent position of a star is totally different from actual position of a star. Second point. Gravitational lensing. Next, Einstein ring. Tell me, in which chapter you people have seen this kind of discussion? Anyone? Space technology. Where in the space technology I told you everything? Where is space technology I discussed with you? James Webb Telescope. I told you James Webb Telescope has given the evidence about all the features of light bends due to effect of gravity. But these all discussion under Einstein general theory of relativity I'll discuss during discussion of particle physics chapter. Understand? Did you understand? See, those lecture particle physics you are listening, guys. Kindly 2 to 3 times you listen. Reason you already know very well. It's an experimental, it's a technical. But still I simplify the technical parts according to demand of UPSC. Clear? So 2 to 3 times you should have to listen. And by the way, it is available on YouTube right now. It's more easy for everyone. That's why I can tell you. Now the biotech ka bhi basic wala part that I told you, GNA and John chromosomes wala, that I also recommend to many people. Space technology mein wo orbit wala concept. I always spoken to the student, please read it. Mobile generation may be step by step. है ना? कि how the generation change. You should have to read it. Understood? So this particle physics wala, so you see 3 to 4 times. Okay, and I wanted to keep this lecture there, guys, because to open our eyes for every aspirants, at least in these locations. Those people are doing the preparation of UPSC. In such a way, they will connect with me. If somewhere I'm going to miss still, not with the help of my book and with the help of my own R&D. Okay, so at least with the help of the videos, people will listen it. And people understand literally one of the teacher is teaching the science ethic as a subject like a history, politics, and same environment also. You already have listened my environmental classes, everybody. And this is the reason. Kindly share this video to everyone. Share it.
Yes, sir.
Everyone share. Yeah, तभी तो people will know कि science ethic it's a very beautiful subject. And even very easy subject. And even they can solve question paper also. Girls, you are not telling. Why is you have a less sound?
Yes, sir. Yes, sir.
I'm very smart teacher, you know very well.
Yes, sir. No, sir.
No, sir, people go out. Okay. And the fifth point and the last point, write down. Fifth and the last point, you write down. Fifth and last point, gravitational waves. Fifth and the last point, write down gravitational waves. So now I have a question. Okay, I have a question here, guys. Which person informed first about the existence of gravitational wave? Einstein in General Theory of Relativity. In which year? 1915. 1915. And you know, gravitational wave existence proved in 2015. 100 years, approximately, experimentally proved gravitational wave exists. 100 years back. Okay, Einstein informed. How much this person was genius, guys. When you have money, you set up the laboratory, then have done the study, and finally you research and you got. So that person was more genius, or these people are more genius? That person ideas based the research is going to perform today, guys. See God particle. You detected the God particle after 2010, and the man about the God particle told in 1924. Yes or no? After 210, you discovered the God particles, CERN experiment. And 1924, where this Bose-Einstein is telling like God particle. Yeah, Satyanath Bose is telling God particle. Matlab that period of time wala scientist. 70, 80 years back, the person informed about the God particles. So Satyanath Bose was also very genius, guys. So जो आदमी 100 साल पहले की चीजें थियरी में बता देता है, जिसको after 100 years you are going to prove it, guys. Did you understand how intelligent he was? Now each and every concept I will explain. Each and every concept I will explain. What are these, guys? The one. Universe is a space, time and matter wraps in its surrounding. What is the meaning of this? See. Actually, for this understanding, okay, everybody see towards me, guys. Universe is on a fabric. Brahmand ek kapde par hai. Try to understand. Okay, in such a way you people understand the concept of space-time. Now every statement I'm going to discuss. Gravitational wave in the last I will discuss. Huh? Even my topic is the gravitational waves. But before it I want to complete it, and then gravitational wave I will start as a separate topic. Okay, and gravitational wave, let me check after lunch, yeah, something. If you are not getting hungry, then okay, sit. If getting hungry, to hungry. So it will be not on YouTube. In that case, it will be not on YouTube. Choice yours.
Yes, sir. We'll make notes.
We'll make notes. Okay. Okay, then fine. 50 minutes more. Listen, guys. This Brahmand is a space-time. Brahmand is a space-time. What is in my hand? Not Brahmand, is space-time. This time I am Einstein. Einstein is going to simplify the concept that Brahmand is on the cloth. समझो कैसे समझो? Brahmand एक कपड़े पे है, और उस कपड़े में there is a two axis. The one is a space and second is time. So how many axes are there? Two. Two axes are there. Okay. As I'm telling you, try to understand. Similar way, guys, the Einstein also informed about universal space-time. So this is universe like a cloth, and this cloth have about two axes. The one is the x-axis is space and y-axis is the time. A different mass of object, my mobile phone, bottle, glass, remote, pen, digital pen, madam your tablet, है ना, bag also, है ना, watch also, है ना, chair also, very good, chair also, है ना, chair also, है ना. Ravi sir is not here, okay. Ravi sir describe. See, if every object I'm going to put here, guys, on this fabric, you can understand very well. On the basis of mass, their bending nature different. Those objects have a massive mass. That area have a maximum bending. Yes or no? Yes, sir. And this bending is called z-axis. X-axis is this. Y-axis is this. Bending is z. Up see, feel. Z-axis is there. So curve is like this. Curve is like this. Curve is like this. See this picture. It's a very interesting concept, guys. See this picture. And in this picture, you will understand very well what I want to tell you. I think it's not Google. Let me open Google. Google. Come Google first. It's Google? No, Google is not coming. I don't like to go on Google actually.
It's not a problem.
Again, it automatically Yahoo. छोड़ो, not required. You complete here. No matter. No, you complete here. No, I'll discuss it. No problem. I wanted a very good photograph where 3-4 objects was there on the cloth, but okay, I'll simplify here. Okay, this picture I'm going to make. No. Okay, I'll decide. I got this. This was the picture I was searching. Already available. Wow. See. Open image in a new tab, okay? Yes, very good. Come. You image.
Visual search.
Visual search. View image. Very good. I told you are not ready to listen me. I was telling you, but you are not ready to listen me. There are 3 objects here, guys. A, B, and C. This is what? X-axis. This is what? Anyone you can tell as a space or time, not matter. But you know very well, guys, this was looking like massive heavy object. And that's why in this area have a maximum bending. Yes or no? This area got maximum bending. This area have a minimum bending. See, why bending is here? Because of mass. If mass is there, what happened there, guys? Gravity is there. You should be very clear, guys. Due to presence of mass, gravity happen. Attraction happen. And this is the reason, guys. If any of the celestial bodies here, so they are under the gravity and they are under the attraction of the objects. Einstein. Due to presence of mass, what happened? Gravity exists. Up see, this is the reason, guys. This object is going to surrounding up this. This object is going to surrounding up this. Object is going to surrounding up this. As I can give you example, Earth and Sun. Why Earth is surrounding of Sun? Because of this space-time. Did you understand or not? If I ask you guys, why Sun is surrounding? Sorry, why the Earth is surrounding Sun? Because Sun have a more mass and Earth is under attraction. Understood or not? And because of certain speeds, the Earth is not going inside the Sun. But if Sun gravity increased, so possible Earth can go inside the Sun. But everything is maintained. Don't worry, guys. Same thing in the case of Earth and Moon. Earth, Moon. If I'm going to keep these two objects here, guys, Earth and Moon, which one have a more gravity, more mass? Earth. So what have a more bending? Earth. So Moon will be under the attraction of Earth. So I think you understood very well, guys, what are going to be happening in the Brahmand. It's all the feature of space-time. Did you understand? Yes. If I ask you why Earth is revolving Sun, tell space-time. Matter wraps in its surrounding. Matter is what? Earth is a matter. Whatever I told you, I prove it here, guys.
In case of Jupiter, if another planet will attract to Jupiter or
depend on the distance of gravitational waves. Depend on the gravitational waves. That is another concept. Many factors work together. Understood? Only the science and environment, so you will not get select, guys. Many factors will work together. Every factor when you club together, then selection happens. Every factor will be work together in that way. Abhi I'm going to discuss only one concept. Understood? So why Moon is revolving Earth? Tell space-time. Why Earth is revolving Sun? Tell space-time. And see, Sun is also revolving someone.
yes.
And to whom Sun is revolving, that is also revolving someone. In this Brahmand, everyone is going to revolve someone. यानी हर कोई किसी ना किसी के चारों तरफ घूम ही रहा है. Don't take it more seriously. Understood? And this is the reason in this Brahmand everything exists. Moon is revolving Earth. Earth is revolving Sun. Sun is also revolving someone, and that is also revolving someone. Galactic year and cosmic year, लाखों करोड़ों साल जाके आते हैं. Earth is revolving 365 days, one time. And Sun is revolving someone, my God, how many years? And to whom the Sun is revolving, it is also revolving someone, cosmic, galactic, my God. पता नहीं million trillion years में how much time it complete one. Okay, one more statement, guys. If I'm going to increase this mass, massive and massive. If I'm going to increase this mass, massive and massive and massive, so what happened? Gravity increase, massive and massive and massive. Yes or no? If more and more mass I'm going to increase, so what about the gravity increases? And the curve is not like that. Curve become like this. My God. Curve became here like this. Curve became like this. And in this kind of curve, what happened? Okay, if any object will come here, come here, come here, because of massive mass and density and gravity, if massive gravity is there, they will go inside and nothing will escape. In this case, this place will call as a black hole. So what is the black hole? Those discovered in the Brahmand universe. This is such area, guys, where the massive density and mass and gravity is there. That is, if any object is getting close, they will go inside and nothing will escape. Even light, etc., nothing is going to pass from there. Anything is going to come because of massive and massive density and gravity. Everything go inside. That is called black hole. So black hole concept you can also understand very easily, guys, with the help of space-time. Not understood? So what are the black hole areas in the space, guys? These are those areas where have a massive and massive mass, density, and gravity. If those mass of Sun today have, and because of this the Earth is revolving. If the mass of Sun those today have, if I increase 1,000,000 times, so gravity will be more or less. More. And Earth will go inside the sun, nothing will escape. Not understood? So the concept of black hole you can also understand very well with the help of space-time. Clear? Space-time. Ab now come, second point. What is the second point here? Universe is constantly expanding. Please, I already proved redshift effect. I already proved under redshift effect. You remember? Universe is constantly expanding or not. Third point is not required. Galileo experiment, two different mass of object fall down. The different it's what? Vacuum kind of condition, no problem. Both will reach on the same time. Now come here finally. Light bends due to effect of gravity. What is this concept about light bends due to effect of gravity? Okay, see here. What happened because of light bends due to effect of gravity? Actually, for this concept, I'll open another photographs. See this blue color wala image. Suppose this is sun. This is earth. This is earth. And this sun have gravity. This sun have gravity. This is a sun, and this sun have gravity. Mass or gravity. This is one of the star. This is here. This is one of the star that is here. And this starlight is going in such a way. Starlight is coming in such a way. But due to presence of sun, the light is going to bend and reach here. Can you understand this picture?
Yes, sir.
The light bends is a starlight. It's an actual position of a star. It is the actual position of a star. Try to understand. Actual position of star. The light is coming here. But you know, light has one property. What is the light property? Light always coming from straight line. Somebody knows very well. Light has some property. Light always come from straight line. Straight. मतलब light has a one property. Light हमेशा एक ही line में आती हुई दिखती है. It's a light property. The light always come from the straight line. Up due to straight line in feature, guys, from the earth, we found the star is here. We feel the star is there. The actual position of a star is here, but star appear here. It's an apparent position. It is what? It is a apparent position. This is apparent position of a star. I think you understood very well. So actual position of a star is here, guys, but star is going to appear here. The actual position is star here, but apparent position of star here. Did you understand or not?
Yes, sir.
And why it is being happen? Because of sun gravity, mass or gravity. So light bend due to effect of gravity. Because of this, what happened? Apparent position of a star is different from actual position of a star. Draw this picture. Better. Draw this picture. You can understand very well. So apparent position of a star is totally different from actual position of star. This picture will help you to understand everything. Clear? Now I'll tell you about the two more small concepts, hardly 5 minutes more. Okay, about what's the point? Gravitational lensing. And the next one is Einstein ray. Actually, this phenomena is called gravitational lensing. Finished? This phenomena is called as gravitational lensing. So this phenomena is called gravitational lensing. What is this gravitational lensing? Very simple, guys. Because of this feature, this kind of feature here, because of this kind of feature here, light is going to divert. You know, the lens have some feature, diversion, conversion. So your light is going to divergent. Somewhere is going to bend. So it's a lens phenomena. This all the phenomena here are going to appear as a lens kind of feature that you people are going to use on your as aspects. Understood? The light is going to change, diverge, yeah, converge or something. Ultimately, this all the phenomena here appearing as a lens type. Okay, it is the gravitational lensing phenomena. Why the term gravitational? I'm telling you that this session I will do after break. That is called gravitational waves, gravitational force. It's a natural force. Gravitational force, you remember during discussion of Aditya Talman what I told you? It is a natural force. And that gravitational force will be after after the lunch which I'll discuss with you. Okay, in that cases, what is the concepts? Third is the Einstein ring. Next concept is what? Einstein ring. What is the meaning of Einstein ring? See, guys. Actually, those phenomena appear here, guys. I'll show you one picture again here. Actually, not only one starlight is coming towards Earth, you people know very well. Only one starlight is coming towards Earth, yeah, every starlight is coming towards Earth. The millions and millions of the stars are in the galaxies and all, even fine. This is a picture that is being captured. Even James Webb telescope also captured that picture, guys. Any picture I can open. So any picture I can open. Okay. It's a sun. It's a sun. It's a sun. Actual sun is here. But in the surroundings, some ring kind of structure is going to form. Understood or not? picture you can understand or not. Why it happened, that I'm discussing, guys. Star is here, 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 star is here. If any of the lights are coming, star lights, so definitely every star lights are passing from sun areas, where sun is the nearest star. Rest of all the stars are so much far. So whenever any stars or lights are coming towards Earth, everybody will pass from the sun or not. Now suppose, guys, I'm here. Okay, I'm here, and one student is already here. Anybody try to come towards me, so you should have to pass from this impact or not. The same thing here. You understood or not? So I just want to, but the universe is a 3D. Here you are in the 2 dimension, you and me in front of them. But universe is a 3D. Any starlights coming from there, everywhere. Sun is very close to me. So it is bent. So light is coming here, they're also coming under the impact of bending. They are here, they're also coming the impact of bending. Also coming in the impact of bending, So bending from everywhere, any the starlight is coming, they're coming in the impact of them. 3D may just try to imagine right now. So this is the reason, guys, from anywhere if light comes, tell yes. Whatever I have done in the earlier discussion, same thing I am doing here, guys. A single starlight is not coming. Achha, you just think, guys, whenever you select your amma house, nani house, Ajji house, grandmother house, you see, sometimes they start looking there. After some time, what happens? Suddenly they start. Don't know where. Why? The earth position is going to change throughout the night. Yes or no? And this is the reason star gone somewhere. I think now you people very clear. Yes, sir. Just when I was going to sleep, in that time here, after some time suddenly I open my, star is not there. Star is not there. Array, you are not here. Your earth carry you some other place. Every moment of time, where the star position look like is going to change. Because of earth revolution. Even earth rotation you can call. Both are working together. And this is the reason the same star and everything will not look like appearance every moment of time. After some time the star position is going to change. Because your position is going to change. Because every position is going to change. Because everything are going to change with the respect of time. Einstein general theory of relativity. सब गोलमाल है, सब गोलमाल है. Clear, everyone? Okay. Up now, next heading is the gravitational waves, and you go and take your meal, etc. So after it, definitely, you are right. Very good. It is very important, very important. है ना? Baki rest of all, you do this study and everything available here, guys. And see, those topic I taught you. This PDF is already shared on my Telegram. Matlab this question, है ना? And many questions you are able to solve right now, particle physics. Okay, you go and solve it. Some of the questions that you are not able to solve right now, that we will discuss after lunch in the next class. Clear? So take it from my Telegram. That's all. Thank you. Advertisement very important.